All right, guys, so sorry about that connection we had. We're looking now at section 4.4. One thing I wanted to talk about from the last section before we get going was the cinnamon bun recipe. I remember last semester this gave some of my students quite a bit of a hard time. So this is the kind of the format we're going to be going with forward. I'm going to have the workbook, and then I'm going to show you guys the work over here in this whiteboard. So just bear with me as I go back and forth, and if you have questions, just like make a note. You can even put what problem I'm working on and then let me know after, and I will go back over it. So again, last week we were talking about fractions. This one says cinnamon bun is number 71 from 4.3, and I want to talk about this before we get into 4.4. A recipe for cinnamon buns calls for 2/3 cup of heavy cream. How many batches of cinnamon buns can be made with 8 cups of cream? So let's go over here and just talk about this a little bit. So we have, this is number, was it 71? Okay. So we have 4.371. So what we have is we have 8 cups. So we have 8, forgive my horrible pictures, 4, 5, 6, 7. These are not even remotely equal. Sorry. 8. So we have 8 there, and we want to know if each batch needs 2/3 of a cup, how many batches can we make? So the idea is if these were each split into thirds. I'm just going to show you the picture so you can visualize, and then I'm going to show you how to do the math. Okay, so each one. So that means here's a batch. There's one batch. Here's 2 batches. Then this third and this third makes a third batch. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, I know it's tedious, 11, 12. So basically what we're trying to figure out is how many 2/3 are there in 8? Does that mean that we're multiplying? No, because we don't want to know what 2/3 of 8 is. We want to know how many batches of 2/3 are in 8. So that means that we're going to be dividing. That means we're going to do 8 divided by 2/3. If you want to know how many, like let's say each recipe needed 1 cup, we would say 8 divided by 1. But the only thing now is that we have 2/3 cup instead of 1 cup. So remember, when we divide, that's the same dot flop. Remember, we change it to a multiplication problem, and we multiply by the reciprocal. Same dot flop. Let me erase those little parts, sorry. So now when we multiply, it's the same thing saying 8 over 1 times 3 over 2, and we just multiply across. So we have 8 times 3 is 24, and 1 times 2 is 2. Well, remember a fraction is just division, so what's 24 divided by 2? Or how do we simplify that? 24 divided by 2 is 12. And remember when we did our little picture here, we found out that we could make 12 batches. So here's the picture, but here's how you do the math. And this is what I always preach. If you're having a hard time knowing how to do it with fractions, switch out that fraction for a whole number that you know you can easily visualize or understand. Like I said, let's say you knew you needed 2 cups of flour per batch. So you would say 8 divided by 2, and you can make 4 batches. But here, just replace that with 2/3. So that way you go back to the fraction. That's how you do number 71 from 4.3. Just want to make sure that was clear. I know it's a quiz problem, something that gives people a lot of problems. So now so last time we talked about how to multiply and divide fractions. Remember when we multiply, we just multiply across like I showed you in the cinnamon bun recipe. To divide, you switch it to a multiplication problem, same dot flop. So let's talk, oops, clear page. All right, so now we're going to talk about how to add or subtract with the same denominator. So this one, you don't need to worry about finding a common denominator. We're just looking at the same denominator. So here, when you have 2 fractions that have the same denominator, we add or subtract the fractions by adding or subtracting their numerators and keeping the same denominator. So here we have 2 divided by 6. Here's your little pie of 6. You have 2 shaded region plus 3 divided by 6. So you have the 3 on the bottom here. If you were to add it up and color them all, you have 5 over 6. So all you do is add the numerators and keep the same denominator. So here the process, add or subtract the numerators, keep the same denominator, and then simplify. All right? Important notes, be careful that you add or subtract only the numerators and not the denominators. That's another common mistake. Don't mess with the bottom when you have the same denominator. When a fraction is negative, place the negative sign in its numerator before adding or subtracting the fractions. When more than two fractions are being added or subtracted, follow the same process. Remember how we would just do left to right. So add or subtract the numerators as indicated and keep the same denominator. So here you have all the same denominators of 7. So you do 3 plus 1 is 4 plus 2 is 6. So 3 sevens plus 1 sevens plus 2 sevens equals 6 sevens. Fractions with the same denominator are called like fractions. Fractions with different denominators are called unlike fractions. And we're going to talk about that next. So let's go ahead and do a couple of problems. So here on your turn, part A, we have 2 over 15 plus 7 over 15. So we have the same denominator, so we just need to add the numerators across. That would be 2 plus 7 over 15, which is 9 over 15. All right, so for this part B, that was part A. Part B, we have 7 over 10 minus 2 over 10. So again, we have the same denominator, so all we're going to do now, we're subtracting instead of adding. So now you have 7 minus 2 over 10, which equals 5 over 10. All right, that one's pretty easy, right? Let's look at when we have a negative sign. So over here on your turn, we have 11 twelfths plus a negative 3 twelfths. So let's look at 11 over 12 plus, plus negative 3 over 12. So remember what it said is that you want to keep that in the numerator. So we have the same denominator, but in this case now we're going to say plus 11 plus a negative 3. Well, when we add a negative, that's the same thing as subtracting. So that's the same thing as saying 11 minus 3 over 12, which equals 8 over 12. All right. Now down here, let's do on your own. I want to do one example with 3 right here so you can see how to do that. So we have part C is 9 over 25 plus 3 over 25 minus 11 over 25. So again, we have the same denominator, so all we need to do is look at the numerators. 9 plus 3, and remember we're subtracting here. Subtract 11 all over 25. Well, 9 plus 3 is 12. Minus 11 gives us 1 all over 25. All right. So now we're going to talk about finding the least common denominator of two fractions. So this is going to come into play when we start adding or subtracting fractions that have different denominators. So this is really going to be important for the next part. So soon we will be adding or subtracting fractions with different denominators. The basic idea will be to rewrite the fractions with common denominators. Here we will focus on the process of determining what that common denominator should be. We will not add or subtract the fractions yet. The least common denominator, LCD, of two or more fractions is the least common multiple, LCM, of the original denominators. We have two different methods of doing this, or excuse me, 3 methods. Method 1 is listing multiples. So here what you do is you start, in this case we have find the least common denominator of 1 over 6 and 7 over 8. That means our two denominators are 6 and 8. So that's what we need to focus on. We don't care about our numerators when we're finding the least common denominator. We only care about the denominator. So we're going to look at the multiples of 6. We have 6, 12, 18, 24, and then we list our multiples of 8, the other denominator. 8, 16, 24. And the way you do it is you stop when you have one in common. More often than not, you'll recognize that. So I look at 6 going down. Once I hit 24, I know that's a multiple of 8. So I know I can stop there. Sometimes it's not as obvious, but in that case, it was pretty obvious. So then we did say the least common denominator of 6 and 8 is 24, or the least common multiple of 6 and 8 is 24. The least common denominator of 1 6 and 7 8 is 24. Finding LCDs by listing multiples is time consuming with large numbers. It works really well for small numbers like 6 and 8 or 7 and 50, or maybe 7 and 4. But once you start getting up into bigger numbers, it's really time consuming and it would not make sense. If you had something like 256 and 13, you wouldn't want to mess with that. So there are two other methods that we're going to be using probably more throughout the semester, so get very familiar with these. Method 2 is the division method. This is very similar to when we were looking at simplifying fractions in the last section and we used the division method, but now we're going to be doing it with both the denominators. And I'll show you how. We'll walk through this example and then we'll do some on our own. The idea is that you start with the same structure. Remember before we had that little division bar upside down kind of thing with just the one number, but now we're doing with both numbers. And we still start with our 2, 3, 5, 7. Remember, this is the list of our prime numbers in order, starting with smallest and just going up. It says etc. here because we would keep going, but I think more often than I don't think we're ever going to see it where you have to go over 7. So you start the same way. You start with 2 and you divide it into both numbers. So 2 divides into 6 and 8 evenly. You end up with 3 and 4. Now I go, can I divide either one of these numbers, 3 or 4, by 2? I can still divide 4 by 2. So I list 2 again, and I just carry that 3 down because it's not divisible by 2. So now 4 divided by 2 gives me 2. Now are 2 or 3 divisible by 2? 3 still not divisible by 2, but 2 is. So now I carry that 3 down. This 2 divided by 2 is 1. So now I'm done with that column. I'm not worried about it anymore. Now I need to figure out this 3. It's not divisible by 2, but it is divisible by the next prime number, 3. So 3 divided by 3 gives me 1. Once you get to this 1, 1 right here, 1 and 1, then you're done. So then you take those numbers right here, 2, 2, 2, 3, and you multiply them to get the least common denominator. So now you can see right here when we listed multiples, we got 24. Here we get 24. You get the same answer. It's just the method is different of getting there. It's like getting from one side of town to the other. You can do it multiple ways, but you still get from point A to point B. All right, method 3 is the prime factorization. So this is where we use our factor trees, like those little trees that we did before. So here we have again 1, 6, and 7, 8. The prime factors of each. Again, they don't show the work, but what they did was that factor tree. Remember, here I'll show you real quick. You have 6 is 2 and 3. Those are both prime, so you're done. And then 8, you had 2 and 4. And 2 and 2. These are both prime, so you're done there. Okay, sorry about that. So then you end up with 2, 2, 3, and 4.